Welcome to stairs. So I'll do a little stair introduction first. We'll go over some terminology and then we'll tackle a straight flight problem. Let's have a look. So we've got a couple of pictures here. Let's look at the first one on the left. General terminology. When we are doing math for stairs, we always want to have, or we're working with a total rise that we use to find the number of risers and how many risers we're going to have. That's always from the finished floor to the finished floor. Then we have a finished opening. Then we have something called the headroom. So that is from our nosing line. I'll get to that in a moment, to the underside of that upper floor construction, so that as we walk down, there's enough space that nobody will hit their head. We have something called the nosing line. So we have the rise and the run of our stairs, and we have what's called a nosing. If you look at that picture on the right here, that's usually the little part that sticks out. It's not absolutely mandatory that we have it, but usually we add it because it makes the stairs more comfortable. And that nosing line just touches the tip of that nosing, and it goes all the way from the top all the way down, and for our mathing purposes later, it actually goes past all the way until it hits the ground on that lower floor. We have what's called the stringer. So this is our structural part that holds the stairs up. And of course, we have our total run. So the distance horizontally that our set of stairs will take up. Now on the right here, it's just a little bit more zoomed in. So here, that's our upper floor construction, same as you can see over here. Our run is always the same, right? It's from the front of the riser board to basically the front of the riser board. And when we add nosing, all it does is shift it over, but it doesn't change anything. So it's called the unit run. Our unit rise, so just our rise, is literally how much does it go up or down vertically with each run. So the run is always horizontally, the rise is always vertical. And then when we actually go to build them, we are working with a riser and the tread. So this is the riser board that we will pop in to make sure that it's a closed stair so dust and grime doesn't fall through on whatever is below. And what we're stepping on are called the treads. Okay, so that's the basic terminology. And you'll find soon that the headroom here that we're creating a little bit of a triangle to find out the finished opening at the end. So let's move down and we'll look at our problem. Let's have a look at the specifications first. So our stairs are used privately, so within a dwelling. That's important because the unit rise and unit run maximum and minimums and the headroom is different for private or public stairs. We have a total rise of 2790. We have a desired rise of 200. This is a number that's important to remember. As per National Building Code here in Canada, the unit rise in stairs for private stairs is 200. That's the maximum. So when we figure out our unit of rise, we need to be mindful to stay below that. Unit run is given to us at 260. The upper floor thickness, so the upper floor construction, is given to us as well at 195. And we have required headroom of 1950, which means the minimum. And that's just the number that we're going to go with. Then we have a nosing of 15 mils. Okay, so before I draw a picture, I like to start my math because the kind of picture I want to draw, I wanted to actually have the amount of risers and runs that we're dealing with so that if we wanted to count, if we forget some of the steps or how to do them, we can actually just count and see what's happening. Makes it much easier. So let's start. We have a few values here that we want to find, and we'll just scroll down. So we want to find the number of risers, the actual unit rise, how many treads we have, the unit of bridge. I'll get there in just a moment. The length of the nosing line, that's important for our layout. The total run, BC, which is the headroom in the floor, and AB, which is the calculated opening length. But no worries, we'll get there in just a moment. So hang tight. Okay, so the number of risers. Easiest way to find that is to take our total rise of the stairs, total rise, divided by our desired rise. So let's pop in those numbers. Total rise, 2790 divided by our desired rise of 200. Let's see what that gets us. So punch that into the calculator, and that gets us 13.95. So can we have a tread that's only 95% of a whole tread? No, of course not. So we need to round. And because we're closer to 14 here, we are rounding up to 14, but be mindful that if this number is ever something 0.25, but the desired rise is very close to the maximum unit rise as per code, just double check to see if you can round down or if you always have to round up. So always be mindful of whatever code you're working with. So we have 14 risers. Awesome. So now to find our actual unit rise, we take our total rise again, and we divide by our number of risers. That gives us the actual unit rise. So 2790 divided by 14, and that will get us 199.3. So we're just squeaking in here as per code. So now that I know how many risers I need, I can draw myself a picture. And of course, I could have pre-drawn a picture for you, but I want to show you just how easy and fast it is to actually just draw something. And I always recommend that you do. So we have 14 risers, so I want to actually draw in 14 risers. So the one off of coming off the upper floor, that counts as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Whoa, 14. Haha. I just kept, oh no, it disappeared. Okay, one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There we go. Boop. This is an awkward line to draw. Yeah. Okay, so never mind that it looks really awkward, but you get the point. I'm drawing on a pen pad, and the drawing on it can be a little bit awkward. It looks very janky, but that's totally fine. So I can count, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 risers. Great. So we did that right. Wonderful. Now, the amount of treads, as you can see, we start with a riser and we end with a riser, which means we always have one tread less than risers. So I like to put myself, I like to put a little arrow here. Now, the unit of bridge, if we go all the way back up to where there is a good picture of our rise and our run, the unit of bridge lives right here. It's part of the nosing line, and that's what really makes up the nosing line. And we have our unit rise, our unit run, and then unit of bridge, which goes right in between. So you can see that this is a triangle and that the unit of bridge actually creates the hypotenuse of that little triangle, and that's exactly how we calculate it. Let's go back to our problem and the super nice drawing of the stairs. So unit of bridge, we take our unit run and our unit rise to calculate. And Pythagorean, so it's unit rise squared plus unit run squared. So if we pop in those numbers, unit rise, we had to figure that out. So 199.3 squared plus 260, that was given to us squared. Gets us how many? Punch that into the calculator. Remember to square root. And that gives us 327.6. So that's important to remember because now the nosing line goes all the way from the top, and it's supposed to, of course, touch the nosings at the front there, but it goes all the way to the ground, which means we take our unit of bridge that we just figured out and we multiply it by the amount of risers that we have, because it doesn't just stop here, right? It just keeps on going all the way till you hit the ground. So our nosing line is our unit of bridge, also sometimes called unit line length, times number of risers. Okay, so unit of bridge, we just figured out 327.6 times 14. And that'll give us a number, 4586.4. And this number is important for if we want to buy material to actually build those stairs, because it has to be the length of the nosing line and then a little extra to give us a little extra room. Now, the total run is the unit run times the number of treads. And if we go back up and look at our picture, we have our unit run for each of these times however many we have. So that's pretty easy to remember. Let's pop that in there. So unit run was 260 times 13 treads, right? And we already figured that out up here, and we always have one less tread than risers. So total run, 3380. Now, the BC headroom and floor. So we had a few specifications up here that I haven't actually put in yet because I didn't want to overwhelm you right from the beginning. So our headroom, I'll draw in my janky nosing line. Oh, that's actually pretty good. All right, nosing line, right? Okay, the headroom is from the underside to the nosing line, right? So that right here is our headroom. And it's given to us at 1950. Up here, UFC, often called the upper floor construction, is 195, right? That's also given to us. It could also be given to you in ceiling finish type of flooring system we have, and then floor finish. So you might have to add all those numbers up to get your upper floor construction or upper floor thickness. In this case, it's given to us. So this whole headroom plus U of C gives us something that's called BC. BC is also called the drop to line of flight. There are just several ways that everything is called. So now you've heard both. Okay. The AB will be the calculated opening. And you can see that AB and BC here actually creates another triangle. And this triangle is directly correlated to our unit rise and unit run triangle. So we know what our BC is, right? We're going to add our headroom and our upper floor construction together. And we know what our unit rise and unit run is. And that's what we'll use to figure out AB. So that goes right from here, from our header to the header on the other side, our calculated opening. So let's figure those out. So we have our headroom and the floor. Headroom was 1950 plus 195. That gets us 2145. Now that's important to remember. So AB, one more time, this right here, the calculated opening length, and where we will compare the triangles of BC, or the drop to line of flight, to AB, our calculated opening, and we'll compare it to our unit rise to unit run triangle. And we're going to do ratio and proportion to figure that out. So the way it goes is unit rise over unit run equals BC over AB. So let's pop in the numbers that we do know. Unit rise, we figured that out, right? 199.3. We can scroll up and have a look. There it is. Unit run was given to us at 260. BC, we just figured out 2145, and AB is what we do want to find out. So this is where we can do ratio and proportion. 260 times 2145 divided by 199.3. And that's going to give us the AB measurement, or the calculated opening length, 2798. So this is the calculated finished opening length. If anybody ever asked you for the rough opening, just like in windows and doors, the rough opening always has to be bigger. And then, right, because we add on the finishes like drywall and nosing. So that's our AB, right, our calculated opening length plus finishes. So it can either be regular 75 mils or 3 inches, or the finishes might be given to you. So either or, but that's how you find the rough opening of it. So really, these are the nuts and bolts of your stairs. Any problem you encounter, double check your specifications. Once you find out the amount of risers that you have, draw yourselves a picture, either as beautiful or more beautiful than what I drew for you here, and put in all the information that you can. That way it'll help you out. And what I didn't draw in earlier, which I could have, is our total rise here of 2790, right? So you just draw yourself a picture and you put in everything you can. Because if you forget what you have to do to figure out various parts, by drawing the picture, you can greatly help yourself. And you might just figure it out. Yeah, from there, we figure out the number of risers, so total rise divided by desired rise. That number we have to round because we can't have one step that is an awkward number. Round up or down, always be mindful of code requirements. And then the actual unit rise, again, is your total rise divided by the number of risers, which gives you the actual number. Treads, we always have one less than risers because we start with a riser and we end with a riser. Our unit of bridge is the hypotenuse of our unit rise and unit run triangle. And this is a nice one to have for your layout when you actually go to lay out a stringer. Our nosing line is just that unit of bridge times number of risers because it comes all the way down to the floor. Total run is our unit run times the number of treads. Then we have our BC, or drop to line of flight, which is our headroom plus our upper floor construction. And then to figure out our AB, the calculated opening length, we're comparing small triangles to big triangles. So unit rise over unit run equals BC over AB. And then we pop in those numbers and we solve for AB. And that gives us the calculated opening, which is the finished opening. If you were asked to find the rough opening, you want to add the finishes that are given to you, header, drywall, nosing, that kind of thing, or add 75 mils or 3 inches, and then that should be plenty.